I'm going to switch this over to science and technology. What will block 2 be? So block 2 will have the bigger upper stage cake, and then block 2 is going to have what's called a BOLE booster. So the BOLE boosters are I think they call it BOLE or something. They're booster obsolescence and life expectancy. What that does, what those things are, so these SRBs, just like the shuttle engines, are left over from the shuttle program. So that is a steel casing. It's a steel casing SRB. And the steel casing ones with the triple O-rings, yes, those O-rings, are very good. They're really good, but they're good if you want to reuse the boosters. Now, once again, another criticism that I have is that due to the infrequency of flight, they basically disregarded getting the boosters back. They tumble and then they hit the water and shatter into a bajillion pieces. Now, I really don't like throwing away stuff that that was designed to be reusable. That's really annoying, but I'll trade it for boots on the moon. That's fine with me. I don't like that we're just getting rid of all the shuttle stuff. That pisses me off, but I prefer to be on a space shuttle launching parts into space to go to the moon, but oh well. So these are steel casing boosters. The BOLE boosters are carbon composite. Actually, it's carbon fiber. It's carbon wound fiber. They call it carbon composite boosters. They're way lighter, but they put the same amount of thrust out because they're not steel. They're carbon fiber, and they're stronger than steel. It's more designed for a one-time use, though, because heating up carbon fiber is... you don't really want to do that. But you don't want to heat up steel either. Yeah, the carbon composite boosters are going to drastically shed a ton of mass off of these things. And the lighter the booster is, so the boosters are kind of like your first stage in this design. The lighter that first stage is, the more mass you can basically use for payload. So if each one of these sheds like 5 tons of mass because it's carbon composite and not steel, that's 10 tons more payload throw mass, I should say. Weight has nothing to do with it. Talking with some shuttle guys, they want NASA to recover those boosters, not because of the reuse, but because they learned something every time they brought the shuttle boosters back and fixed it. Yeah, I agree. Agreed. They should put chutes in them, Rev, and then go contract out SpaceX. Seriously, go hire SpaceX, get Bob and Doug, the fairing recovery ships, get them out there. Get them out there to pull those boosters back. Just like Freedom Star did. Watch the LAS wiggle. No, they're not going to recover those. They're going to eventually replace them with carbon SRBs. They should, but I agree, Rev. They should get them back. But reusing SRBs, guys, only makes sense if you're doing a high frequency of flight. The reason why that makes sense when you're doing high frequency of flight is the same exact reason why SpaceX reuses fairings. It's not that a booster is complicated. SRBs are complicated to make. No. They're not complicated to make. They're not really that expensive. It's that they take time to make. You have to basically, the grain inside of these segmented SRBs, you need to bake it like a cake. It has to cure. And that takes a long time. So what do you mean bake it like a cake? Well, okay, so the propellant or grain in the industry, SRB propellant is solid rocket propellant is called grain. I don't know why it's called that. That makes sense, I guess, some weird way. Grain silo, whatever. So the grain takes time to cure. You have to cast it like concrete almost. And then, I don't know if they autoclave it. I don't think they do. It's more like concrete, less like baking a cake, I suppose. But the propellants that they use, hydroxyl terminated polybutadiene and ammonium perchlorate with an aluminum flake stabilizer. Yeah, they burn aluminum. The SRBs burn aluminum for a stabilizer to keep the explosion nice and even, so you don't get cavitation inside of the SRB. That's a bad idea. So they burns aluminum. It's so metal it burns metal as fuel. Aluminum's a great fuel. Seriously. You ever see a plane catch on fire? When it catches on fire, there's no plane left. It's just a char mark on the ground because aluminum is great propellant. Interestingly enough, you wouldn't think about it like that, but it's great solid propellant. But that whole substance, that whole forbidden cookie dough. It looks like cookie dough. It really does. It looks like gray cookie dough. I'm not kidding. That whole thing takes time to cast. So the production hurdle, if you're going to use a lot of SRBs, is not necessarily, the cost. It's the time it takes to make the propellants. That's why with the high frequency of flight with the shuttle, SRB reuse makes sense. Just like with the high frequency of flight of Falcon 9, reusing fairings makes sense, even though it didn't cost a lot of money to make said fairing. Reusing them is a flight bottleneck, not a production. Well, it's a production bottleneck, so it becomes a flight bottleneck. So reuse actually makes sense. Once again, SpaceX took that idea with fairings, the idea that they got from the shuttle for reusing those SRBs, and they applied that to the fairings, which it's smart. I mean, it makes sense. Also, Falcon 9 I just want to point out that Falcon 9 has launched like how many times? 13, 14 times already this year. Just on a side note, okay, 8 times. 8 times already. Sorry. Yeah, it's 8 times. The next Falcon 9 launch is the 9th Falcon 9 on the 5th, which is crazy. Yeah, actually, the one yesterday was the 8th, so 7 in January, which is just absurd. You need to wait for the prop to die and the composites to bake. Yep. Fairings actually, yeah, that's the thing. I should mention that. Fairings actually aren't that expensive to make. You have to bake the fairings in a gigantic easy bake oven. And when I say a gigantic easy bake oven, it's called an autoclave. It basically heats up stuff and it pressurizes. So it's literally a pressure cooker that's the size of a small building that they have to put that whole fairing in. Remember, the fairing on Falcon 9 can fit, the 2 fairing halves can fit a school bus inside. So we're talking about an oven that you could drive a school bus into easily, or any type of bus. The autoclaves, they're in Hawthorne. That's where they make, they're actually behind where the announcers commentate. You can actually see them, which is actually really cool. I always try to point it out when I see it, but SpaceX hasn't been doing video views of the hosts inside of Hawthorne or anything, which is, yeah, can't really point them out too much. But drive a school bus into an oven, man, that will make the news. Yeah, Deuce, that's what I always try to do. When I explain rocket science, I always try to find ways that people can kind of understand. It's an oven that you could literally drive a bus into. And you have to bake the fairing at super high pressure so the carbon fiber cures to the aluminum. Because fairings are basically, if you could like punch a hole in a fairing and look at a core sample from a fairing, it looks like an Oreo cookie. Only the filling is aluminum. And the cookie part is carbon composite. They make an aluminum shell of the fairing and then they wind carbon fiber on the inside and the outside of it. It's the fairing, and that's supposed to make it so it's lightweight, right? And you have to bake that so literally like baking a cookie, so the carbon fiber basically adheres to the aluminum. If you don't, it'll just come unwound when you go to launch, right? So SpaceX with Falcon 9 and the fairings aren't expensive to make. They just take a long time. That's why SpaceX is basically started reusing fairings, because their factory would not be able to keep up with the frequency of flight if they expended the fairings every time. That's part of the reason why we see Falcon 9s launching once, twice a week. Pretty crazy, right? Why are there lots of patterns on the tanks? It's not a smooth metal surface. All of them not welding, is it? Oh, okay. What patterns are we looking for here? They have to do the same thing with Formula 1 cars, Sebi. Yeah, Formula 1 cars chassis, the carbon fiber monocoque is built like a fairing. It literally is a fairing. I just want to point out that the boosters are burning so bright, it looks like daytime right next to the pad. So are we talking about this right here, hooded? That is an instrumentation marker. They can use this footage and compare that checkerboard to other checkerboards on the vehicle to see if the vehicle is actually deforming. And rockets do that. When you light those engines at the bottom, the whole vehicle compresses. And When you have something pushing up from the bottom and you have gravity pushing down on the top, it can twist the vehicle. You think your vehicle wobbling around in KSP when you go to launch it is not normal? Oh, dude, that happens with every rocket. Seriously. Watch the launch abort system. Right here. 3, 2, 1. Booster. Watch it. Ready? It'll... You see it wiggle around? That's hard to see. It's hard to see in that camera. No, like dents on a car. Okay, so let's look at the vehicle staging adapter. What are we talking about here? I'm trying to get a shot where it's actually in focus. Oh, you're talking about why does it have this stuff right there? Okay, so I gotta sneeze. Turbo. There we go. Sorry, it's building up a lot of boost in there. Thank you. So, okay. Hooded, before I get into what the orange stuff is, check it out. See the checkerboards right there? The reason why they have a lot of checkerboards right there is because they're looking for deformation around the SRB attachment point. Pretty cool, huh? That's why all that stuff is there. They're not QR codes, I swear. They're looking to see if the hold down point, see the hold down piece for the SRB right there? It's basically a gigantic pin that goes through a slot that attaches on a strut that goes between the SRBs. They're looking for deformation around it. So, just a little word on the checkerboards because we were already talking about it. So right here, this stuff, that's Sophie. Spray-on foam insulation. Okay, you ever see like somebody that has like a cold drink in the middle of the summer and they put it inside of that foam? That. It's literally that. Why? Well, same reason why you'd put a cold drink in there. It's an insulator. What this does, what the orange stuff does is increase the performance of the propellants. The reason why is because this insulator keeps the propellants cool. It keeps the propellants colder for a lot longer. So you squeeze more performance out of them. It's foam. They spray it on like spray-on insulation inside of a house. Same kind of idea. Are they detecting the deformation? They're detecting the deformations by cameras. Well, it's cameras backed up with the telemetry sensors. You know there's a load sensor in there somewhere. There's definitely a load sensor in this design somewhere. I wonder how they apply that foam evenly. A mold injector? Dot dash, they put the tanks on a giant rotisserie. Think like rotisserie chicken. And then on the side, right, they have a spray gun that's mounted on a track that just goes back and forth. And then they just rotate it, and it works like a typewriter. Just back, rotate, back, rotate, back, rotate, back. Actually, it doesn't go left to right. Sorry, that's not the real right way to explain it. They're actually just constantly spinning it, and the thing goes this, and they do one revolution, and then this, and then one revolution, and then this, and then one revolution. I did it backwards. But see the lines on the spray-on foam insulation? See how they're going left to right? That's because they spin it 360 degrees, apply the foam, and then move the spray gun down a little bit, and then spin it again, apply the foam, and then move the gun down a little bit, and then do it over and over again. They spray all the tanks before they put the whole thing together. That's the reason why this color foam right there, hooded, is a different color. Because this foam was applied after the LOX tank joined the intertank right there. See how it's a different color? The foam reacts in the sunlight. You can always tell how recently this stuff was applied because when it first gets applied, it's like a really light cream orangish color. And then it really gets into that deeper orange when it's been sitting out in the sun for a little while. Now this core stage has been sitting out in the sun for a little while because it's the one that they green runned at Michoud. They did the test flight. They did the test firing with this thing. But between the test firings, they did reapply foam at the seams because it cracks. See, they reapplied it right here, and you can still see there's some cracks in there. But see where it was all reapplied? That's why that foam is lighter. Because between the green run and the actual launch, they went and reapplied that stuff because they wanted to inspect the seams in here to make sure nothing cracked. Yep. Yeah, they cake everything in the spray-on foam insulation. Once again, it's called SOFI. S-O-F-I, spray-on foam. And you know what? I might be able to get you... I know there's pictures of the SOFI jig. They, it's this big... It looks like a big paint booth, to be honest with you. I'm trying to see if we can find a picture of it. It's cool, man. Thanks a lot. Yeah, no problem, dude. There it is. That's it right there. This is a paint booth. But it's a paint booth for applying foam. So even bigger than the school bus oven? Deuce, you could fit 2 or 3 school buses inside of the LOX tank, man. 8.4 meter diameter. That's 25 feet in diameter. Like, that's width. So the core stage is like maybe the size of a 3-lane highway. Something like that, dude. It's pretty big, man. There's a reason why they have to move this by barge. Okay, you're from South Africa, you know meters. Thank you for telling me, because I never know. I have to give both measurements because I don't know where anybody's from. That's what I try to learn it, so I don't have to make the distinction. But I usually try to give both measuring systems. And Deuce, for what it's worth, I know either one. And yes, I'll admit metric is easier. Yes, I get it. I get it. You don't need to tell me. I get it. So this right here is actually before the foam is applied. Because this is made out of aluminum, this is like, I think it's 7000 series aluminum that's been friction stir welded. They paint it with anti-corrosion primer. That's what this is. Lex Friedman podcast with Tim Dodd just dropped, and it's over 5 hours long. Oh my goodness. Man, Tim wasn't kidding when they said they went over the limit. What the frick is this? Who linked this? This Friday will be sussy. Someone says meters is measured. I'd say it's easier to understand, Razzie. I don't really care what the measuring system is, dude. That's the truth. I'm sorry, that pisses people off. Every time I say this, people get mad, but I don't care. That's the truth. I really don't give a frick. Is that a plane? No, that's not a plane. No. Oh, you didn't know that? I had heard whispers, Tessa. See, guys, I got a problem. My favorite European car manufacturer is Ferrari because Italy. But my favorite American manufacturer is Ford. And if Ford gets back into Formula One, I have no idea. I don't know who. Am I gonna have to become Orange Team fan? Ugh. I was joking. It's my problem. I have difficulty with the American measurements. It doesn't make any sense, Raz. I get it. It doesn't make sense. It's not base 10. It's not easy to understand, but it is cool. Like, very nice. I don't want to root for Max Verstappen, man. I hate that guy. Yeah, Casimir, let's just piss everybody off. It's just a license. Red Bull just slapped a Ford badge on the engine. Haven't you seen Ford versus Ferrari? Base 12 is more divisible than base 10. Gem, it really, honestly, I didn't grow up with metric. But I learned metric, and it's easier. But also at the same time, It's what you grow up with. I can understand feet and miles just fine. No problem. I don't care. Like, that's the thing. I don't care. Like, we can measure it in bananas if we really wanted to. If you want to measure distance, we'll measure distance in standard bananas. I don't care. It doesn't really matter to me. Root for Carlos, then? Red Bull's prospective engine deal with Ford is leaked in the Italian media. The two will join forces as partners for the 2026 engine regulations. It is understood. Red Bull's 2023 season launch is in New York on Friday. No comment from Red Bull. Dude, if they partner with Ford, I guess I'm a Red Bull fan now. Crap. Well, no, I don't. Toad stubbed me up. Yep. I don't know. Yeah, I'm not really sure what I would do in this scenario, because Ford was in F1 for a long time, and they were good in the 80s. And then with Benetton in the 90s, right? That's right around when I got into it. And then there was the Jaguar Works team, and we don't talk about the Jaguar Works team. We don't talk about that. Kazi engines are awesome. Oh no. Ford Cosworths. The DFV is one of the most Chadliest engines ever devised by man. The DFV. What a masterpiece of engineering. You may not like it, but that's what peak mechanical engineering looks like. That motor was in Formula One for 20 years. 20 years. They were able to iterate on this design and make it better for 20 years. It was competitive into the 80s. It's a motor from the 60s. There is not many other engines that are like that. It's right up there with Ferrari's Colombo V12. It is one of the Chadliest engines around. You like big American muscle cars? That's good, man. Razzie, you can like both of them. I love Ferrari. Ferrari's my favorite. I'm no Lamborghini fan. I don't like tractors. You can go make tractors over there. Ferrari's where it's at. I mean, Razzie, also, you know, where my nonna comes from is Parma, which is not far from Maranello, so it's the same state, same valley. Ferrari. Up there with a Ford 300, that motor is indestructible, dude. I've never seen anybody kill a Ford 300, with the exception of like one. I saw a video on YouTube of a guy that held the thing at redline for like 30 minutes. That's what it takes to kill one of those things. What a Chad tier motor that is. Anyway. Yeah, that's the spray-on foam insulation thing. And then you can see the jig over there. It's basically similar type of robotic arm that they use to paint cars, that an automaker would use to paint cars. You see it over there? M12. Oh no, I see you're a man of taste. I knew I liked you. Yeah, they put the tanks on these gigantic rings. See that? And there's basically just a drive wheel right there, and it can rotate the tanks. It makes it easier to work on. Things are easier to work on with the tank when you're plumb with gravity. So, say you want to attach something right here, right? It's hard for a crane to get down here and then attach stuff to the side. So you rotate it to the 12 o'clock position and then just drop the thing right on it. Don't drop it, but yeah. So most rockets, guys, I don't know of a rocket that doesn't do this. These are called processing rings and the processing jig to move the rings. I tried to make this in Kerbal. It's a little bit difficult, but I'm sure if we revisited it, we could do it right. Dot dash, nice. Coming from the guy who said the AMC 4.0 was indestructible. Yeah, well, there's the thing. There's the thing about that 4.0. When you hold it at redline on the highway for 30 to 40 minutes with bad rings, yeah, you'll probably break it. And 200,000 miles. It's almost like that one's operator error and not necessarily the engine design. Look, don't blame the engineering for your shortcomings. All right? Learn how to take care of your vehicle next time, and you won't have to replace the engine.
Discovery, go at throttle up.
Wrecked. Get wrecked. It wasn't redline. Something foot to the floor, 85 miles an hour. It has 200,000 miles on it, man. You got to baby it, for frick's sake. Oh. And I'm pretty sure the previous owner sold it to you because the motor was starting to go. But whatever. Don't worry. It costs $200 to fix it. No problem. Don't kill this engine. $3,000 RPM with bad rings. Ooh. Ooh. All right, let's see how bright it gets right here. Your uncle has 320,000 miles on his Tundra. That 1UZ motor, the 5.7 liter 1UZ that Toyota makes, is a very, very underrated V8. It's a really nice V8. And I'm saying that as an American. I know V8s. That's a really nice engine. Or if you put your 4 liter through a river, that in fact kills it. Yeah, something hydrolock. Something. One UZ engines, man. They're really, really good motors. Non-interference engine. I mean, it doesn't make a lot of power by design being non-interference, but it's still good. This one is in super slow-mo, huh? Oh, this is sick, dude. You see a lot of LS motors. I guess they're okay. Dudes, what makes LS motors good is that they're not trying to do anything. It's a tried and tested design that you know works. Think like Merlin engine of car motors. Like, that's what an LS motor is. It makes really good power. The design is so well iterated on because it's literally not that far off from the small block Chevy that Chevy made in 1963. They have a lot of data on it. That's why LS engines are so good. Because you're not trying to do anything new. You're just trying to do what you know and do it better. It's literally iterative design applied to car motors. But I can still floor it occasionally, right? That motor does not like revs. It really doesn't. Inline sixes make a lot of torque on the low end, but they don't like being revved, especially high displacement ones. It is basically a small block Chevy. It's not that far off. In fact, LS motors and small block Chevys can bolt to the same transmissions, if I'm remembering right, because Chevy is a master of interchangeable parts. That's why people like Chevy so much, because you can literally take the crankshaft out of a 400 and put it in a 350 and it'll work. Easy to fix. Yeah, it is interlaced, isn't it? Inline sixes are very revvy, boss. Well, 3000 cc and under ones. High displacement ones, Tesla, still suffer from the rotation from a long stroke, right? If you have an inline six with a low stroke and small bore, you can rev it to the end of time. 2JZ, RB26. But engines like a Barra engine, like the inline six at 4, that's a 4 liter inline six. That thing does, I mean, you can rev it, but got to be careful. Spinning that much mass can be costly if you danger to manifold. Yeah, see, Tesla, that Jeep motor, the 4 liter Jeep engine, is a super long stroke, super small bore. So it's because it's designed to make torque. That's what it was built for. What is the Dodge equivalent of the LS Coyote? The Hemi, the Gen 3 Hemi series, the 5.7 liter Hemi. Another good engine. Really good. That's a really good design. I mean, Tesla, big bore, short stroke. I prefer equal. Equal is where it's at, dude. Equal bore, equal stroke. Why have one or the other when you can have both? Equal bore, equal stroke, small combustion chamber. Rocket ship. Like Ferrari's 3 liter V12. That's what I'm talking about, man. Oh, dude, look at that. So see the hydrogen coming out of the engine when they start to spin the pumps? Each one of those bright flashes is an engine ignite. And look, There you go. Sequenced ignition. Watch. Ready? Skadoosh. Hemi stands for hemispherical. There was some hemispherical part on the Hemis, and that's where it got its name from, or am I confusing that? Only 3 liters. There's no replacement for displacement. Ferrari was making engines in the 60s and the 70s that could rev well over 10,000 RPM. There is a replacement for displacement, and that's called revs. Yeah, revolutions per minute. Oh yeah. Oh yeah. The Colombo V12 dude can easily make more power than like a big block Chevy. Oh yeah, no problem. That's what made Ferraris cool, dude. But if you're gonna rev something like that, you have to really make sure the vibrations don't kill the motor, right? So every part is precision engineered, precision balanced. That's what's cool, man. That's what makes a sports car, dude. I mean, muscle cars are awesome. I love muscle cars, but it's literally a truck engine in a car. Like, it's a truck motor in a car, guys. That's what it is. It makes great torque because it's a truck motor. Yeah. Dude, as I get older, dude, don't get me wrong, I love my big block cars just as much as the next guy, but that precision engineering is sick, dude. Oh, that is righteous, man. You leave the Viper alone. It's a truck motor that they put in. But hey, you know what? It works. Whatever. There was a Honda 250 bike that revved up to like 20K. That's what happens when you have small displacement with a really nice balanced design, dudes. You can rev to the end of time. That's why people like Honda engines so much, guys. That's why the K24 is such a good motor. It's a simple motor that is really nice and balanced right from the factory. That's why people like 2JZs. Same thing. I mean, you're not going to make a lot of torque on the low end, but dude. Whoa, is that the interlacing or is that thing moving around? With Ferrari, I think it's impossible to make repairs to the engine. Well, Raz, if the engines are blueprinted and you have to replace a piston, for instance, yeah, no, it's not. That ain't going to end well. Why is this camera interlaced? I'm not 100% sure why it's an interlaced picture. Yeah, I think that's interlacing on that strut right there. Holy crap, dude. This is really high shutter speed. Look at this footage. Dude, I could sit here and look at this all day. Oh, they didn't even get... They cut the camera at booster ignition? Oh, come on! I don't know why that camera's interlaced. That's very strange. Ooh. Look at the exposure on this one. Man, it's... So you use a really low exposure like this to get a really nice contrast during engine ignition. So you should be able to really, really see the flames coming out of the rocket motors here. Oh, element. Yeah, I know what you mean. See? Yeah, that exposure, the exposure rate is really getting you some good contrast on the igniters. Yeah, Jack, something weird was going on with that picture. I'm sure there's a reason why it's like that, but this one is not interlaced. This is a progressive picture. So once again, those sparkers right there, dudes, are there to purge out all the hydrogen. Because to spin these things, they basically shoot nitrogen through the turbines to get the fuel pumps started on the rocket engine, right? And when you do that, they already have the fuel lines full of fuel because they need to get the engine down to its right operating temperature. Similar to a car motor, because we were just talking about that. Car motors need to get up to the right temperature to perform correctly, right? Rocket engines need to get to the right temperature to perform correctly as well. The thing is, because you're using super cryogenic propellants, and you're going like minus 200, minus 300 Fahrenheit here, the operating temperature of the engine is actually super low. So they have to bleed the engines and get them to cool down. Because when you fire it, you don't want to flash freeze a propellant inside of the engine. That makes explosions. That makes a hard start case. Hard starting a rocket engine would be like trying to start a car with your pedal to the floor. Like, pedal to the floor on the gasoline and then turn the key. It's not good. You don't want to do that. This breaks the car engine, and that breaks the rocket engine as well. Or like trying to start a car in gear with your foot to the floor. It's just, yeah, you're going to break something, right? So the engines are super chilled down. So when they shoot the nitrogen in to start the engine, the engine pukes out a little bit of atomized hydrogen and oxygen. And if you don't give that hydrogen and oxygen mixture a place to pop, it's going to find a place to pop and blow up in a place where you don't want it. The idea is to get it to explode where you want, right? And not give it a place to, like, not worry about it and have the hydrogen go pool somewhere else and blow up on the pad. Yes, that does happen. I'll give you an example of a rocket that does that. A lot of you guys know what I'm about to show you. So the Delta IV has an open cycle rocket engine. So when they go to start it, the fuel pump dumps hydrogen into the flame trench, right? And the resulting thing that happens is literally a gigantic fireball. Watch. Because if you don't give the hydrogen a place to go, it's going to find a place to go and do that. Now, don't get me wrong. On Delta IV, no, this is not a human-rated rocket. It's fine. It's really not that big of a deal. But, dude, look at that. When they first started, when ULA first started flying Delta IV, and before them it was McDonnell Douglas and Boeing, right? When they started flying Delta IV, they were firing the engines like 1, 2, 3 in really rapid sequence, and dude, the whole rocket basically blew up on the outside. They found ways to mitigate it by igniting one engine and then a couple seconds later igniting the center and the side booster. You could see that was the first engine to ignite because that one was the most scorched, that side booster. This is what happens. You don't want this. You don't want that happening on your rocket with people on it. Yeah, you do not want that happening. So if you don't give the hydrogen a place to pop, it's going to find a place to pop. And yeah, remember, SLS is shuttle derived, right? It's a shuttle derived launch vehicle. I don't think I need to say why you don't want to see that fireball happening on a shuttle, right? That's why they came up with ways to get rid of it. Now, another thing to take into account, and this is for the nerds here, this is for the really nerd people, like, okay, so the R68A on Delta IV is an open cycle engine. So it dumps a lot of gaseous hydrogen overboard because they use hydrogen to drive the fuel pump. On the shuttle motor, it's called a closed cycle engine. The fuel pump exhaust gets dumped into the rocket motor. So you don't really have as much hydrogen like escaping out the bottom. So you don't get that big of a fireball because the RS-25 is a closed cycle motor. But you still need to give it a place to go. If you don't give hydrogen a place to explode, it'll find a place to explode. And if it finds a place to explode, that place that it finds is probably not going to be one that you want. Case in point, you don't give hydrogen a place to explode, it's going to find a place to explode. And yeah, it's probably not going to be good for people. Did that still happen when they had solids on the side for Delta Medium? Yeah, a little bit, Jack, sure. Yeah. Hydrogen makes things go boom. Really, 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 really nicely. Yeah. Turns out when you fill your dirigible with gaseous hydrogen, and then to save weight, you make the outside covering basically out of the same stuff that they line SRBs with. Yeah, it makes for a pretty good party, I guess. Yeah. Yeah, we've had an anomaly. We have to secure the area? Anyway, that's why you give hydrogen a place to pop. If you don't give it a place to pop, it'll find one. And that place that it pops is not one that you want. I guarantee that. But what's the deal with Kamaz trucks? What? Huh? What are you talking about? Fun fact, the reason why the Germans used hydrogen in their dirigible design is because they were getting helium from the US and we embargoed the frick out of them. We were like, yeah, you guys are, I don't think that's how you should run a country. Yeah, you don't get any helium. So they were like, well, fine, we will use hydrogen. Oops. All right. Just fun fact. We need to bring them back. Maybe safer this time? Yes, dirigibles are a cool idea. I just don't really see the application. Like, what are you going to use it for? Oh, 9. All right, so here, see the orange flame? That's that hydrogen being purged off. Hydrogen burns orange. It burns orange when it's fuel rich. If it burns clean with oxygen, the flame should be clear. You should be able to see right through them. The idea of cargo blimps have burn. Burn? Oh my gosh, you're sending a probe to Eve. I'm short about 4,000 meters a second delta V. I may have miscalculated somewhere. Or your delta V indicator is not reading correctly. Deuce, sometimes the DV indicator, like the stock one in KSP, the one that's over here on top of your staging, sometimes that doesn't read right. The idea of cargo blimps have been floating around. Oh, okay. Yeah, you hit enter too early there. I wish you'd finally drop some of the military restrictions on Germany. I want an aircraft carrier. That's like the only thing that would make me want to serve. I mean, the Graf Zeppelin existed. Sebi, that was kind of cool. Like, I don't know how well a cargo ship would be, like a cargo dirigible. I mean, dude, look at that. Oh, dude, it's hypnotic. I could watch this all day. I have been watching this all day. I just realized that. Boosters. Look at how violent the booster ignition is. Holy crap. It's creating turbulent air above the freaking nozzle. I mean, don't get me wrong, most rocket engines do that, but that's a lot of turbulent air. Oh. 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 They changed the exposure. The camera exposure changed right there. And it switched to 4.3. Or no, this was in 4.3 the entire time. Isn't Germany landlocked? No. No, not at all. One of the biggest ports in Europe is in Germany. Oh yeah, dudes. These things... So, rocket engines move the gas so fast that it pulls the gas that's around it down. And it creates a ton of low pressure right here. Oh my god, look at that thing. Mein Gott. So yeah, it creates a vacuum. There's actually super low pressure in here, and it'll suck anything down with it, which is nuts, dude. Unfreaking believable, man. Look at that. I'm looking up, like, I can look up. It's a screen, man. See? That's the shuttle engines. Sorry, I know they're RS-25s. I'm still going to call them shuttle engines. My bad. Look, that is a perfectly healthy hydrogen engine. Good, healthy hydrogen engine, flames should be perfectly clear. Because the only thing you're accelerating out of that is water vapor. Seriously. A combustion byproduct of H2 and O2, H2O. True story. Oh, that footage is awesome. This is the coolest footage. This is my favorite thus far. There's so much going on. Is that high quality H2O? Yes. Yes, it is. Dude, look. An interesting thing, dudes. Check this out. See the thermal blankets on the nozzle right there? So that's a boot for the nozzle because the nozzles move, right? And if excuse me, if they move, you want a sealed environment inside of the booster skirts in there because there's the equipment like the hydraulic system that's used to move that nozzle, right? You don't want any explosions finding that or else you can't steer, right? That's like the engine room for a ship, right? You don't want anything getting in there because you won't be able to steer the damn thing, right? So the interesting thing here is that they cut it off. It's sealed. And there's actually two little umbilicals that if we could see through these flames, they'd be right there and right there. It's a nitrogen purging system. So believe it or not, inside of the aft booster skirts right here, it's pressurized. And the crazy thing is that this is creating such a...
Discovery, go at throttle up.
Hazareth! Thanks, man. This is creating such a vacuum and such a low pressure environment that the booster, the boots actually inflate. Watch. There's such a low pressure differential and comparatively to the positive pressure inside of the aft booster skirt that these actually inflate after liftoff. Watch them. They'll inflate. See, look at that one. It'll actually blow up like a balloon. See? Oh, that's so cool. That's how low the pressure is right there, dude. We're talking like maybe like at least half atmospheric pressure. Like I don't want to put a number on it because I don't know, and it's sometimes, you know, it's better to just say you don't know, but it's low enough to inflate those bags, you know? Like I've seen footage of them pumping like a gazillion liters of water onto the pad. You guess it's to prevent the pad from catching fire. There's two reasons why you'd want to spray water on a pad, okay? Oh, actually, there they are. They're on this side. That's the nitrogen purging system for the aft booster skirt there. These are the hold down points. There's 4 of them on each booster. So 1, 2, 3, 4. That right there is the booster nitrogen purging system, just on a side note. They're on this side. I forgot what side they were on. I couldn't see them I couldn't see them over here because they got covered up. Those things get a little bit warm. Fun fact. So, okay, 2 reasons why you'd want to spray. Actually, 3. One of them is what you said. There's 3 reasons why you'd want to spray down the pad. One of them is a pad deluge. Okay, so the pad deluge system is usually below the launch deck of the rocket. So the launch deck basically is the surface that the rocket is attached to right here. See, that's the launch deck. So pad deluge systems are usually down inside of the flame trench. So what do? What does a pad deluge do? Well, it dilutes the flames coming out of it. It's basically there to protect the flame trench because the rocket engines get a little hot, and the deluge system is there to basically quench the flames and give that heat somewhere to go so the heat for the launch pad doesn't absorb the heat and melt. Yeah. This has a deluge system in it, but this also has a sound suppressor. Sound suppression systems are above the launch deck. That's the difference between a deluge system, and a sound suppressor. Now, that's what this stuff is. See all that water? That's this. So, okay, what does a sound suppressor do? Well, it does protect the pad, Deuce. That's what it does. It protects the pad. It gives the heat from these engines a place to go. Because these things are going to push out a lot of heat no matter what. I don't know if you noticed, it's a little warm right in this area right there. See that? Yeah, a little warm. It's really freaking warm right there, but you wouldn't tell because hydrogen. But it's also very warm right there. So you got to give the heat a place to go, because if you don't spray a bunch of water on this thing, that heat's going to go into the pad and melt it. Your pad will hit critical mass, basically the maximum amount of heat that the material that it's made out of can absorb before it literally becomes liquid. Now, that's not why it's called a sound suppressor. It does do that. It gives you a thermal medium here because water absorbs heat really, really well. Just fun fact. The reason why it's a sound suppressor, and this is the kicker. So, okay, if you think about like what a submarine does, picture a submarine floating through the water, like underwater, but still floating. Well, not floating. Okay, neutrally buoyant, we'll say, going through the like underwater. Like picture Red October. What noise does that submarine make? Dong, dong, dong. It's a ping noise, right? Why? Water carries sound. Water absorbs sound really, really well. That's why submarines use sonar and not radar, because you can use sound is a better medium when you're underwater. I mean, heck, blue whales can communicate with each other hundreds of kilometers away by just going, ah! They can hear each other, which is actually really cool. Fun fact. Water absorbs sound really, really well. They spray down the pad with water because the sound coming from these rocket engines is so ridiculously violent. If you didn't have water to absorb it as a sound insulator, the reverberations off the launch deck is enough to shake the rocket to pieces. You can literally damage the rocket after liftoff if you don't do this. They figured out, because water is a really good way to absorb sound, that this actually prevents the rocket from shaking itself to pieces. The sound will reverberate, and you'll get compounding vibrations from the sound reverberation. It's literally reverse. This is sound engineering. It'll bounce off the metal deck of the launch pad, right? And it'll reverberate up, and it'll compound off of the already oscillating rocket, because rocket engines make a lot of vibration. You can compound the vibrations, and if they hit a resonant frequency, something explodes. Yeah, that's happened. Yeah, that's happened. Yeah. Let's just say that early rockets didn't have a sound suppressor, and it kind of shows. They shook themselves to pieces, man. So it's more of a harmonic resonator and damper. Yeah, but it also does protect the pad. So 3 reasons. Sound, protecting the pad, and protecting the flame trench. Now, here's the kicker. Sound suppressors can also be on the end of the flame trench. Sound suppressors are usually above the launch deck, but some types of pads have a sound suppressor that is actually at the end of the flame trench. And that is to dampen out the noise as well. Because even coming out of the flame trench, when the rocket's going off, coming out of the flame trench from the side, you could still get a reverberation. So sound suppressors can either be at on top of the launch deck or at the end of the flame trench. Pad deluge is anywhere in between. Those are 2 different systems. And I know that people kind of use those terms interchangeably, but technically they mean 2 different things. Now, here's where this gets a little bit annoying. Not everybody follows that naming convention in the industry. Some people call the technical thing for like a pad deluge system, they call it a sound suppressor. Technical term for a sound suppressor, they call it a pad deluge. Like, there are technical definitions, but it varies from rocket to rocket, dude.
Discovery, go at throttle up.
Yeah, exactly, Loopy. That's a case in point. STS-1's boosters, so the first shuttle mission, they overperformed so hard. And they didn't spray the right amount of water into the pad because the boosters did better than they thought they were going to do. It literally shook tiles off the back of the shuttle, and they were super worried, like, oh, well, if the tiles are gone, are we dead? Yeah, it shook tiles off the orbiter maneuvering thrusters on the back of the orbiter. Oh, yeah. Oh, yeah. NASA was like, oh, damn. Hey, Canadian gifted us up to dues. There you go, man. Rocket engineering's awesome, dude. But it's all straightforward stuff. That's what I mean. Like, okay, the thing's loud. We get it. You have to find a way to dampen the sound. It's like when you have loud neighbors. Put insulation up, you jerk. Like, same idea. Link for the archives. Don't forget the doors. What about the doors? What is this? Oh, yeah. Yeah, that, dude, the boosters blew the doors off the freaking launch umbilical tower. That's amazing, dude. They solved that trench and sound issue by digging under the launch pad, didn't they? I mean, at Baikonur. Yeah. Yeah, Hooded. Soyuz still has a deluge system. Oh, yeah, absolutely. They still spray water in there. Yeah, but yeah, they chose to dig a huge hole in the ground, Hooded, because that way you really don't need to engineer a flame trench. Give the gases someplace to go. The thing is, in Florida, you can't dig a big hole in the ground, so we have to use flame deflectors. That's a big difference between like Russian pads and or pads in the east versus pads in the west. Just dig a big hole in the ground, because think about where they're launching from. They launch from Baikonur. Baikonur is in the desert. You can dig a big hole in the desert. You're not going to find water, because it's the desert. You have to dig a long way down to find the water table. In Florida, you could literally step on the ground hard enough and it'll make a puddle. So we can't dig a big hole in the ground in Florida. It would become a big swimming pool really quick. And you don't want to fire a rocket engine into a swimming pool like that. There's this thing. You got to spray down the pad. You can't, like, rocket engines theoretically could ignite underwater, like in the case of Sea Dragon, right? But the thing about that is you want to spread the water out so it absorbs more sound. So that's why they kind of spray it on the pad. If you just fired a rocket like over a swimming pool or something, hydrolock, you could hydrolock the rocket. That's not a good idea. Sorry, I had to answer that. Sound suppressor for the shuttle at Vandenberg would have been huge. Could have pumped the whole LA reservoir onto it and it wouldn't be enough. Yeah, the reverberation off the mountains at Vandenberg is something they were worried about. What's the byproduct from Merlin and Raptor engines? Raptor engines, you don't get much byproduct because full flow stage combustion. Apollo, it's pretty damn efficient, about as efficient as you can get from methane. So you get some small carbon emissions from a Raptor engine. Merlin engines, on the other hand, run extremely fuel rich. They roll coal, basically, because kerosene. Yeah, they roll coal. That's why Falcon 9, when it comes back down, looks like it's all charred up. It's not charred up. It's covered in carbon soot. It's the same kind of stuff that comes out of the smokestacks of a diesel truck. Same idea. Yeah, Falcon 9 rolls coal. The reason why they do that is the same reason why you see the smoke coming out of a diesel truck. Now, don't get me wrong. If a diesel truck is tuned correctly, you shouldn't see any emissions, right? But some people run fuel rich in a diesel truck to get more power and keep the motor cool. Rocket engines do the exact same thing. The Merlin engines run fuel rich. They run fuel rich so the rocket engine doesn't melt, because that's a really good way to keep it from melting. So what's the byproduct from a Merlin engine? Charcoal, mostly. Yeah, it's not exactly charcoal, but it's basically the consistency of that. Roll coal. I don't mind rolling coal, Lasered. It's cool, but I do have a problem with the people that, like, drive down the highway and they have their dump pipes pointed right at the cars next to them. That's just messed up, dude. Like, if you want to roll coal out of some stacks, that's pretty awesome. But out the side, that's just a dick thing to do. I'm once again asking for your link support. This is a long link, Zay, but I got you. But yeah, they run fuel rich. Most rocket engines do that. Other rocket engines have different ways of cooling the nozzles. Now, on the Merlin engine, they run fuel rich. That's a big one. They have film cooling. It's not exactly film cooling. Actually, on the Merlin engine, it's open cycle, so I don't know if they're using film cooling. Sorry, I digress. On Merlin engines, they run fuel rich to make sure that the nozzle doesn't melt. The crazy thing is that on the SRBs here, for instance, so with an SRB, let's think about this for a second. Now, if you know the answer to this, don't say it. It's for the people that don't know, right? So think about the solid rocket booster. So on the shuttle engines here, on the RS-25s, they're using the hydrogen. They're pushing the hydrogen through the nozzle. The nozzle basically has a bunch of cooling vanes in it, and they shoot hydrogen through that. That's why when the engines start, they ice over. And then that heated up hydrogen goes into the fuel pump, and then that goes into the combustion chamber, right? Actually, it goes from the low pressure fuel pump to the nozzle to the high pressure fuel pump to the combustion chamber, if you really want to get technical with RS-25 plumbing, but whatever. They're using the hydrogen to cool the nozzle because hydrogen is really freaking cold. It's a fuel-rich stage combustion. That's what it's called. That's the technical term for it. So they use hydrogen to cool it. What about the SRBs? You can't use any hydrogen or anything. Pumping hydrogen from here to there to keep that damn thing cool is going to be a pain in the butt. How would you keep a SRB nozzle cool? How would you do that? Think about it. Like, don't get me wrong. Some of you guys know this. I know some of you guys know this. But if you don't know, how would you keep that cool? How do they do it? How do the SRB nozzles just not melt? I mean, clearly what's coming out of there is really freaking hot. Ablative cooling? LN2? Well, you wouldn't want to use nitrogen because that introduces another commodity into the SRB. There's a simpler way to do it. Black magic? No idea. Air-cooled? Well, air-cooled is not a bad idea, but when you get up into space, there's no air. Somebody said it. The SRB nozzles are ablative. They're made out of a heat shield. It burns off intentionally. But when it burns cooler than the hot gases coming out of the SRB. And that gives you a good enough thermal medium to keep the nozzle relatively intact for 2.5 minutes. And keeps the gases coming out vectorable, that's your word of the day, in any direction. The nozzle's made out of a heat shield. It's an ablative nozzle. Pretty cool, huh? Yep. It burns the nozzle off. And towards the end of flight, the thickness of the nozzle actually goes down because the inside of the nozzle is heat shield. It's made out of a heat shield. I don't know what exactly the SRB nozzles are, but it could be a phenolic impregnated carbon. It's some type of heat shield, something that ablates. Ablation is basically when you burn something off to cool. Oh, we're looking at rocket. Yeah. So they have to change the nozzle after each flight. Yeah, Dio, after every shuttle flight, right before the SRB hits the water, it jettisons the nozzle because the nozzle's wasted. You have to replace it. But you get your casings back, which is, yeah, that's what they did during the shuttle program. Oh, dude. With a diesel engine, you can inject propane similar to nitrous. Could you inject that into a rocket engine? Sure, Mutter. Heck, dude, some rocket designs use nitrous. They use nitrous as an oxidizer. So, Virgin Galactic, with their, the thing that gets launched off of the carrier and goes up, and then it goes up for a second, it comes right back down. That has a hybrid SRB in it. It's a SRB with nitrous injection. Yeah, that's called a hybrid motor. Yeah, they basically use a pressure-fed N2O system to give the SRB more oxidizer to get a little more performance out of it. Yeah, hybrid engines do exist. Nitrous injected, absolutely. You could do the same with propane. Really depends on what you're using for fuel, but yeah, totally a thing. Yeah, Dio, this is good stuff, man. Dude, I eat this stuff up. Not literally, don't eat SRB propellant. It's not good for you. It's forbidden cookie dough, okay? But yeah, this is my favorite, man. This is so cool. It's so smart. That's why I like it. It's so well thought out. Like, you see it and you're like, oh man, that makes a lot of sense. That's really, really smart. It's so well thought out. That's why I love it. Is not sufficient enough to have enough delta V for orbit? Well, Deuce, if you're using it as an oxidizer, sure. Why not? Really depends. You could have a staged hybrid SRB system. Sure, why not? Yeah, it's a pretty good oxidizer. There are better oxidizers, don't get me wrong, like liquid oxygen. It really depends on what you're doing. It depends on the application, but sure, absolutely. Yeah, sure. Nitrous is really good at providing a quick burst of energy in a relatively short period of time, right? It's literally what rocket engines do. You need to expend a lot of energy over a really short period of time. It's a pretty damn good oxidizer. But there are better oxidizers. Like nitrous is gaseous, first of all. It's a gas, and it's only 33% oxidizer. Liquid oxygen, on the other hand, is liquid, and it's 100% oxidizer. See what I mean? There are better ways to do it. Another fun fact about rocket propellants, guys, on a side note, hydrogen peroxide is the only thing that can be used A, as a liquid fuel, or B, as an oxidizer. It can, yeah, with hydrogen peroxide, you could do either one. It depends on what you're using as liquid fuel and oxidizer in that scenario, but yeah, H2O2. It can be used either as liquid fuel or oxidizer. Not both, though. I'm still a big fan of the Russian way to do it. No Rule 8, nothing. Just speaking of the technology. Dio, the way that the Russians run their space program, one, because they don't really have the cash to iterate as fast as we can, but it's very, very, very practical. It's very practical. That stuff is very well thought out because it has to be. It has to be well thought out. I mean, with rockets, guys, it has to be simple. That's what's cool. That's how you can always tell that it was a really good solution to a problem when you sit there and look at it and you go, that's a really good way of doing that. That's really smart. Like the ablative nozzles on the SRBs. How the hell else are you going to keep it cool? Trust me, it probably took them a good while to figure that out. We put the rocket in space. Stand back. Yeah, Soyuz, that's right, Loopy. Yeah, with Soyuz, they literally stick a match up the nozzle. And they stick a match up there, and they leak propellants into the rocket engine. They stick a match up the nozzle. The fumes from the propellant finds the match, creates an explosion, and that creates a vacuum that starts the pump. Yo, yeah. You ever see those YouTube videos of, like, when people have, like, methane gas inside of a bottle and they put a match over it and the flames go down, and when they get to the top or when they get to the bottom, it goes pfft. Literally that with a rocket motor. That's what Soyuz does. They stick a match up the end. Doesn't need to be simpler. Why would you put your starting mechanism on the rocket engine? That makes no sense. It's not like you need to restart it. The rocket's gonna be in a forest in the next 20 minutes. Put the starter motor on the pad so you can reuse it. Fun fact, that's what those do. Shuttle engines can't air start. They really can't. One, hydrogen explosion. You need a sparkler to get it to work. And two, why are we restarting our shuttle engines now? They're only used for ascent. Is that why their engineers only have one arm? I don't know, maybe. More CGI, blah, 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 blah. Your mom's CGI. Got him. Dude, what the heck? What is this picture that they're using? It burned the nozzles at ignition into the lens right there. You see that? What is this? They're getting some nutso artifacting going on there. Was this an expendable camera or something? When the engine ignited, it burned the shadow of SLS into the picture. It is now. Some of the high-speed cameras have had some problems. Yeah, I can see that. Yeah, it burned a picture into the lens. That's how bright that is. And what about ion thrusters? Do they get hot in the vacuum? Nah, not really, Razmio. I mean, they do. They do get hot to an extent, but ion thrusters are basically arcing electricity at high voltage, low amps, through a combustion chamber with inert gas. And when that electricity arcs through the inert gas, it ionizes. And that ionization that happens is what makes thrust from a Hall effect thruster. That does not make a lot of heat. I mean, don't get me wrong, it makes something. It definitely does something. That heat has to go somewhere, but ion thrusters, guys, like if even the one in Kerbal, the ion thruster in Kerbal makes 2 kilonewtons of power. If someone had an ion engine, if someone invented an ion engine nowadays that made 2 kilonewtons of thrust, they would be a billionaire. Ion engines do not make a lot of thrust in real life. They don't, dude, it's like negligible. Like you could do this, like blowing air out, like even whistling. Whistling produces more thrust than an ion engine does. They don't really make that much thrust. They don't make that much power. Yeah, it's basically a spark plug that's igniting inside of a xenon purged combustion chamber. But yeah, they don't make a lot of heat because they don't make a lot of thrust. Like, dude, a desk fan that you use to cool yourself in the summer makes more thrust than an ion motor. Easily. Now, here's the interesting thing, Raz. The interesting thing about ion engines is that ion engines are scalable. You know why they're scalable? Because a spark plug does the same thing that a lightning bolt does, right? It's just an electrical arc, and clearly you can make a bigger electrical arc, right? So you could scale up ion engines. The thing is, if you do that, you need to make more electrical power. And generating electricity in space can be done via a fuel cell, which does not generate a lot of electrical power quick. It generates a lot of electricity over a long period of time, right? Or you could use a solar panel, and solar panels are way more efficient in space because, down here, the gas, our atmosphere, distorts a lot of the light. They're more efficient up there, but even then, it's still a solar panel. Like, now, Raz, if we had a ship with a nuclear reactor on it, which they have tested, the Snap 27, the US and the Soviet Union have tested nuclear reactors in space. They had to make sure that they were letting the other side know that they were launching a nuclear reactor and not the other thing. Funny story. We're launching a reactor into space. This is where it's going. This is what it's going to do. We're just testing to see if it works. This is not an ICBM. Take note. And the Soviet Union did the same thing. So nuclear reactors do work in space. You can make a nuke generate enough power where you could scale up an ion engine and get it to produce some useful thrust. Not really good for human rating, though. Even with a nuke, you would need a nuclear power plant-sized vessel to generate the amount of power that you'd need to ionize gas and make like a useful amount of thrust. So like if we wanted an ion engine that makes 1,000 kilonewtons of thrust, we would need a nuclear reactor like out of an aircraft carrier or something. And now you have other problems to solve. If we're using like like let's just take the CVN-65. Let's take Enterprise's nuclear reactors, the A1W, all right? So the aircraft carrier has nukes on it, right? Not the missiles, the reactors for power. Now, you got to keep that cool. Nuclear reactions generate a lot of heat, and they like to melt things. And that's what a meltdown is when you generate too much freedom. So, aircraft carrier uses the water, because the ocean is cold, and that's enough to keep the thing cool. Now, up in space, you got a little bit more of a problem. There's no water. There's no anything. So how it works, so what is up there? Light? Light? Yeah. Get this. On the ISS, they radiate coolant through a radiator, right? Or they move coolant through a radiator, and it uses infrared to cool. All that heat gets conveyed as infrared, right? And they actually use infrared light to shed the heat off. They convert the heat into, well, not convert the heat into infrared. The radiator basically shines really, really bright on the infrared spectrum because the infrared light is what's up there. We can't see that, but that's what they do. You would need a radiator, a couple of radiators, like, I don't know, maybe the size of a small town to keep a nuclear reactor cool if you're radiating the excess heat. Like, to radiate that excess heat, yeah, you'd need a big radiator to do that. Infrared is okay at radiating heat, but it's not the best way to do it, but it's the only way to do it in space that we know about right now. So, Raz, you could scale up a Hall effect thruster to produce a useful amount of thrust. But the problem is that you need a whole lot of other things to also make that work. But it's doable. I mean, a fusion reactor would be more in line with what we're talking about, like a magnetic containment reactor that basically keeps the heat inside. But we're getting into stuff that's near future tech, we'll call it. The next 20 years, right? Sadly, ion thrusters are severely limited by power consumption and size. That's what I'm getting at, Rocket. You can theoretically scale up a Hall effect thruster. You could make like a Hall effect thruster as powerful as like a TIE fighter engine from Star Wars. But does anybody know why the TIE fighter has those huge vertical wings on the side of it in Star Wars? Because they're solar panels. Because it needs to generate a ton of electricity. Now, dude, that's some solar cell. That solar cell is like near 100% efficient to get a TIE fighter to maneuver around like a fighter plane using ion thrusters. That is one hell of a solar cell, literally to the point where it violates several laws of thermodynamics. It's Star Wars. What do you want? No life support either for a TIE fighter? Yeah. Yeah, that's the funny part, Stuart. Yeah, they're, I mean, the TIE fighter is pressurized, right? But the reason why they have that helmet on in the TIE fighter is, I mean, one, it looks menacing, right? But, yeah, that's the life support system. You're just inside of a pressurized environment at 1 bar, and the oxygen goes to your helmet. Don't take your helmet off inside of a TIE fighter. You will not have a long time to live. It's true. Hey, the Empire wanted to keep the cost down. I mean, it made sense. Hey, the rebels, the damn Botham spies stole the plans to the X-Wing. What do you want? So they had to go with the TIE fighter. I'll remember that next time you're inside a TIE fighter. All right, cool. Sounds good, man. Newest addition to the Space Meme archives. Nice. So just doing some looking at the ML deck camera, SLS goes from same thrust as Falcon 9 to more thrust than a Saturn V in about 0.85 seconds. Very nice. Yeah, Renkar. Yeah, Tim was on Lex Friedman. That's cool, man. Dude, I'd love to hang out with Lex Friedman. That guy's cool. I like his podcasts. He's a very smart dude. 0.85 seconds. 0.085 seconds. Yeah, that's a hell of a compression load to be introduced on the vehicle that quickly, Vulcan. Pretty nuts when you think about it. Oh. There's your sequenced ignition. 1, 2, 3, 4. Like torquing bolts on a head. There's a sequence to it. 1, 2, 3, 4. Seriously, they sequence the engines for that exact reason that Vulcan and I are talking about. 1, starting a bunch of rocket engines all at the same time can create a resonant vibration and destroy the entire thing. 2, they do it, if you're going to sequence the engines, you have to do it in a way that's going to apply equal compression load to the engine section. So you go 1, 2, 3, 4, like torquing bolts down on a head or on a tire on a car. Same exact thing. 1, 2, 3, 4. Cross pattern. It's for the same reason. Now do all 33 of them. That's why, Mutter, that is the precise reason why I think lighting 33 engines off is going to be one hell of a challenge. Because think about the torque sequence, so to speak, to do that. Whew. Do they start at max throttle at launch? Yep. Yeah, pretty much, Hal. Yeah, the engines start with the throttle basically wide open. There's not, don't get me wrong, there's not a gas pedal for the rocket engine. It's all computer controlled. But yeah, you start at 100%. And then you can either go up or down from there. Yes, I said up. Some rocket engines are uprated past their original rating, which is why some rocket engines produce 120% of their original performance, right? So the shuttle engine, or the SLS engines that flew on this were at 109% thrust right after liftoff. So the thing ignites, it goes to 100, and then during these 6 seconds here, right before the boosters ignite, they throttle them up to 109, and then during max Q, they throttle down to 66%, and then out of the throttle bucket, they go back up to 109, and then right towards core stage engine cutoff, they start tailing off. They go back down. Actually, low temp radiators would be very large. It would be much larger than high temp radiators because the energy that gets transmitted goes up exponentially as you get hotter. Most actual designs take these levels of power generation and heat rejection into account, have large radiators for the life support more than for the engines. It's just that engine panels would glow visibly. Interesting. In Starship's caves, would the engine light from the inside or the outside? What would you do, Super? Seriously, what would you do? Would you want to load up one side first? I would start. Well, actually, I'm not going to tell you where I would start. I'm not going to tell you. Where would you start? Inside would be my guess, less of a shock. Bingo. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Well, it goes up to 33. You get what I'm trying to say. I lost count by picturing the engines. But they basically start on the opposite sides and it spirals around, from what I understand. I don't know if that's exactly how they're doing it, but that would be my guess. It's like screwing on a wheel. Bingo. That's part of the reason why you sequence ignition pins, because you do not want to shock load the engine section. If you fired all these at the same time, you'll crumple the rocket like a soda can. It would be like hitting an unopened can of soda with a sledgehammer. Just yeah. So that's why you go 1, 2, 3, 4, 5, 6, 7, 8. You just keep bouncing around. That's looking at the bottom of Super Heavy. These are all Raptor engines. Each one of these produces 2,400 kilonewtons of thrust. And I forget what the... 539,541 pounds of force. So that means that every time one of those engines ignites, it pushes up with the same amount of force that a 540,000 pound block of concrete would push down on something sitting on the ground. Do you want a 540,000 pound block of concrete being dropped on you? Whatever's underneath that thing is going to get crushed. This is why you don't start 33 of those things at the same time, because all of that, 15 million pounds. Do you want a 15 million pound block of concrete being dropped on your rocket? That probably is not good for it. That's why they sequence the ignition. I mean, that's one of the reasons. There are multiple reasons to do it. Okay, Def. Have I seen Scott Manley's video on Columbia? He mentioned that during re-entry, they turn off the front RCS because it would fire directly into the plasma stream and cause instability. Turn off the front RCS? I wouldn't do that, but I can see why it would absolutely do that, Def. Busted. As a concrete guy, I agree. Yeah, that's that thing about concrete. It's pretty dense and it's pretty frigging heavy. Really good at dealing with compression load. That's why they use it for buildings. How many engines gimbal out of the 33? All of them? Okay. Take a guess, zombie. Do you think all of them gimbal? As someone who doesn't want to go squish, I also agree. Yes, no squish. No squish. You don't want squish. Which ones do you think gimbal? I mean, seriously, you could tell by looking at this. Or at least you should be able to. It sort of looks like just the center ones. That's right. Yeah, that's correct. Why? Well, look at the gap between the inner and outer ring. That's a dead giveaway. Also, somebody pointed out, look at how close those nozzles are to each other. Those engines don't move. Those engines do not move. Because if they did, you'd get nozzle touching nozzle. Not good. Not good for it. Not really not good for it. So, these engines are the ones that have thrust vector control on them. Another fun fact about this, and you can extrapolate a little bit more just by looking at this zombie if you really know what you're doing. So, it makes sense that these engines don't gimbal, because these engines are only used for ascent. Falcon 9 doesn't land on 9 engines, right? Falcon 9 lands on 1 out of 9. Sometimes 3 if it's a really hardcore landing, right? Actually, what Falcon 9 does is, if it's a hard landing, it goes 1 to 3 to 1 and then lands. But aside from the point, I haven't seen them do a lot of 1-3-1 landings lately, but then again, either way. So, you don't need as many engines to land as you do to take off. So, these engines are fixed. Why would you have them gimbal? There's no point in doing that. You're just wasting mass at that point. So, this inner ring is enough to create moment to be able to steer the vehicle correctly. I mean, Raptors have 15 degrees of gimbal. That means they can move 15 degrees tilted this way, this way, this way, that way. They can... A good example of it is right there. Now, keep in mind, that's an older booster design with a single center engine. But check that out. They can do that, which is just absolutely absurd. But you need that type of thrust vector actuation to do this. See, look at how much it's tilting. See the engine? That's really cool. So, the outer engines don't have any gimbal, because why would you need that? Also, you don't need these engines for landing, so you don't need the thrust vector control on them, because they're only for ascent. So, they only gave the inner ring thrust vector control. Dude, I'll bet you dollars to donuts you don't even need the inner ring. I'll bet you that SpaceX went with that because Super Heavy doesn't have landing legs. It gets caught by the tower, so you need that extra control, just in case. So you can say, like, they want to pitch, but they also want to roll. Like, you know, so the 3 engines in the center do this, right? To roll the booster when it's coming in for a landing. And then the outer ring can do... Some of them can do pitch and some of them can do yaw. That's why, I guarantee you, that's why they did that, for more precise landing. Because the more thrust vector actuation, the more moment you can put on the vehicle and the more precise you can be with your landing. Think about it. They have more rocket engines here for the exact same reason why planes don't have one control surface that does everything. They have ailerons, elevators, and a rudder. Because one's for pitch, one's for roll, one's for yaw. It's not an odd concept, right? On a plane, everyone's like, yes. But on a rocket, everyone's like, wait, what? No. This makes it so you could pitch, yaw, and roll, and then also decelerate at the same time. You could have rocket engines pointing this way, you could have one pointing that way, you could have one pointing that way. They could twist, whatever. It's for precise landing. Hangman, it's going to be something when this thing comes back down. If they can catch it, I'm serious. That is going to be the crazy. That will take the cake for the nuttiest thing I've ever seen. And I was there for the first Falcon Heavy flight. I saw those boosters come back down. Even that was strange. Do you think they will also use differential thrust? Nah, Rocket Man, I wouldn't use differential thrust, dude. I would rely more on thrust vector control. Rocket engines don't generally like being throttled. Now, Raptor is one exception because if you're making 300 bar chamber pressure, you could pretty much throttle it to whatever you want, and you're not going to have to worry about it shutting off. You can... I'm not going to call it this. This is just kind of an analogy, but you can, like with a jet engine, if you throttle it too fast, right, you can get a compressor stall. You basically flood the engine. Rocket engines can do that too, but they don't compressor stall. It's not what it's called. It's what happens is with a rocket engine, if you lower the combustion chamber pressure enough, you're not making enough pressure inside of the combustion chamber to accelerate the gases past supersonic in the throat of the nozzle. So it screws with what's called your mass flow rate. Mass flow rate is basically the rate at which gases pass through the convergent point on the nozzle. I mean, a rocket engine is just a big hourglass, right? That impingement point is where mass flow rate is measured. How much mass is literally moving out of that per second, right? So it's m dot. It's a lowercase m with a dot over it. That's how you'd represent it with math. Math! So if you lower your combustion chamber enough, your mass flow rate goes... The speed of the gases coming out here is not enough to go supersonic. And if they don't go supersonic, you basically made a nice flamethrower. Long story short, if you don't create a good enough explosion to fill up the combustion chamber, the gases won't pressurize in there and they won't shoot out like a fire hose. It'll just dribble out, and that's flamethrower. That's what a flamethrower does. So throttling the rocket engine, right? Like, don't get me wrong, Raptors can throttle. They can deep throttle. Raptor engines can go down to 40%, which is absurd, but that's what happens when you make 300 bar chamber pressure. That's it. That is an insane number for a rocket engine. That's the true ridiculousness of Raptor. Raptor engines are so damn powerful, you can test the engines down here with an upper stage nozzle on them and you won't get flow separation. The other thing is that, picture the rocket as an hourglass again, right? You got to fill up one side of the hourglass so you can accelerate gases in the center at the impingement point, and then the explosion has to fill up the entire nozzle. If it doesn't fill up the entire nozzle, you get non-uniform heating amongst other things, and you can get cavitation in there, and that kills the nozzle pretty fast. It'll introduce all kinds of weird vibrations into the nozzle and basically blow it up. It'll go right to your thighs, and then you'll blow up. So, hang on. That's a lot of firepower. So you got to fill it up. So they don't use upper stage nozzle. A lot of people don't like rockets don't test with the upper stage nozzle down here. So like on the Merlin vacuum engine, they test the Merlin vacuum engine with no nozzle on it. It just basically looks like a fire hose, just gas is going all over the place. Because you can't, because it'll break the nozzle, because the nozzle's designed to work up there, right? Up there, it's pretty easy to keep that combustion chamber filled with gas because there's no air pushing against it, right? There's no atmosphere to push it to try to creep in the nozzle. So, most upper stage engines down here are tested with the nozzle off, right? Raptor engines, they make enough pressure in the combustion chamber where it doesn't matter. It really doesn't make a difference. Talk about over-engineering, right? It's pretty insane. So, the rocket engines, they can throttle, and the reason why Raptor is good at deep throttling is because of high combustion chamber pressure at 100% throttle. So you wouldn't really want to use, long story short, you could use differential thrust here to make this work. You could, but honestly, you're going to get better moment from a thrust vector control system because the amount of moment that you make from throttling this engine over that engine, you could easily get by just turning both the engines in one. You could get more. Basically, it'll turn it more if you just turn both the engines that way, right? That, and once again, rocket engine throttles don't necessarily work in real time. Think of it like a garden hose. What happens when say you take your garden hose out in the house that people own nowadays? Say you take your garden hose out, you attach the sprinkler to it, right? And you turn on the hose. Does the sprinkler turn on right away? No, it takes a second. Rocket engines work like that. There's a little bit of input lag between the computer and what the engine's doing. And don't get me wrong, that input lag is maybe a couple of seconds, like less than a second, right? but it's enough to make a difference. It's enough to where controlling the throttle like that, using differential thrust to steer the thing, rocket engines can't react that fast. They can't change. They can change the throttle pretty quickly, but not that quick. It'd be better to use hydraulics and use a thrust vector control. Cursed rocket idea, Rofees to orbit. Oh boy. Oh wait, are we talking deep throttle? CECE would like a word with you. Yeah, that's the beauty of an expander cycle. But also, RL10's Vulcan have a pretty interesting expansion ratio for an upper stage engine, don't you think? Might be silly, but what other differences would you find sea level versus vacuum engines other than the nozzles? Cooling mechanism, moto. Yeah, how they cool the engine. So, on Merlin engines, on Falcon, Merlin 1D, the first stage engines, they use film cooling. Well, not film cooling. They run fuel rich to keep the engine cool, right? They run fuel rich. Pretty straightforward stuff. Right? You can't really do that in space.
Discovery, go at throttle up.
I mean, you can. But the nozzle's also baking in the sun up there. So Falcon 9 second stage engine, the Merlin vacuum, has an ablative nozzle in it. But it's film cooled too, if I'm remembering correctly. They film cool it using the fuel pump exhaust. That's that manifold on the second stage engine. You always see it. The ice always gets stuck on it. They're using that to cool the nozzle, but the nozzle's basically ablative. Doesn't need to last very long, right? Like, it's not like you're reusing it. Not yet, at least. They're not reusing a Falcon 9 second stage, just in case anybody's wondering. I'm talking more about Starship. Hey, Maverick 18137 sub. Anyway, good talks, dudes. Want to play some Kerbal? Fun stuff. Rockets are cool, dude. They're pretty simple. They're pretty. The principle of operation is not that complicated. It's doing it that's the complicated part. Making what we just said, all the stuff that we just said, making that work is complicated. You know how I can tell? Does that look complicated to you? It looks complicated to me. That looks like a lot of stuff that I don't understand. I mean, I understand the principles of operation, but that looks expensive and complicated. You saw the ML deck cams too, right? Yeah, Vulcan. Not reusing it yet. Hey, thanks, Mav. Thanks for the bits. Appreciate you, brother. Gotta head back to work. All right, dude. The other reason why I showed this picture, guys, is the Raptor engine plumbing is so ridiculously powerful, it can fill this nozzle, which is optimized to work down here, or it can fill that nozzle, which is optimized to work up there, but it can do that down here. See how much bigger the Raptor vacuum nozzle is? That's insane, dude. If you had to guess, when will the first Starship full stack launch be? Launch and return? It's going to be sometime this year, Hangman, if everything goes right. The reason why it's so hard to predict SpaceX's dates for when they're going to do stuff is because they don't even know when the dates are. The reason why is because, unlike NASA, who does all the testing first, and then you go to do the fun thing, and then this basically is a final exam, making sure you understand completely what you engineered. SpaceX is doing rapid incremental testing, okay? So with SpaceX, it's much more along the lines of like, I'm about to say a generic scientific method, but that's not really the right way to say it. Like, SpaceX tries something, and then they write down the results. The testing is actually, believe it or not, a lot like KSP, where you try something, and does it do what you think it's going to do? Okay, it did. Okay, is that repeatable? Okay, we can do that. All right, cool. That works now. Let's combine that with another thing, right? It's agile software development. Yeah, it is agile, but I hate saying agile and waterfall in here. Sorry, people don't come here to hear me talk about scrumming. Okay, it's true. So, Hangman, the reason why I say it's really contingent, and I'm not entirely sure, is, for the most part, because it really depends on how well their testing goes. Like, I'm not going to give you a good date on like an orbital flight, right? Because they haven't even figured out that they can fire 33 of those engines together, right? That's a big hurdle to overcome, and SpaceX is going to do it. They're going to do what they think needs to be done to get that thing to work correctly, and then see if it does work. And it might not. It might blow up. It's possible. I think SpaceX really is on their game, dude. They've done incremental testing to the point now where they could be reasonably confident in the outcome. Don't get me wrong, that's a very expensive way to test. Remember these? That's an expensive way to do that, but hey, like I said, this is the most expensive way to test, but it also gives you the most data. That gives you the most. Testing like that, actually going and doing actual flight testing instead of just simulation, that gives you the best, that gives you the most amount of data. You learn the most that way, but it's also the most expensive. Primarily experimentalists, not theorists. Well, yeah, Oculus, each way has its own merits. For instance, SLS did 99.9% of what they thought it was going to do. Okay, any software engineers here? Think about how hardcore you have to be to get your prototype software working correct on the first try. Does that happen very often? No. If you're a Kerbal player, you go to build a new spacecraft, you go to build something, and then you fly it up into space, and you're like, yeah, that's not doing what I want. How many times do you launch it on the first try and it works correctly? Yes, because I'm perfect. Every software. Why do software engineers have such a god complex? People are sick. I'm just kidding. Hey, Tweets, how's your day going? Fine. My day's going great, dude. How about you? How long ago was that now? SN9? SN9? SN9 was 2 years ago, Mutter.
Discovery, go at throttle up.
We got to stop referring to Artemis 1 as a flawless launch. I mean, the core stage had an underspeed of a whole 7 feet per second. My code is never buggy. I will create things for a live. I literally create things for a living. I am a god. Minion 64-month resub. Did you finish the station? Smoke, the station is done, dude. We're working on grand touring stuff now. So basically, I'm going to use the stuff that I learned with the shuttle to basically tend to much bigger ships that go a lot further. Yeah. Also, Kraken drives. If you guys didn't watch the end of last night's stream, please go watch it. I used a Kraken drive to get a ship out to the moon, landed on the moon, and back. Landed at KSC with the drive. And the ship was 600 tons. And we did it in an hour and a half. No time warp. And we landed it at KSC like a Dama maneuver style. It was crazy. And then Val died. Yeah, at the end of the test. Yeah, but we were in simulation mode, so it's okay. All right. Yeah, I miss all the good stuff. Oh, don't worry. We'll be doing some stuff. Aqualex, to be fair, paying for the person time to do the simulations over a decade is also just as expensive. This is just a faster way to burn through the same money with just as much of a failure risk as the other way. You're just more likely to wind up spending more money before realizing you're going to fail, and you have to have the money to throw at the problem. Ooh. Yeah, I'm gonna go ahead and have to sort of disagree with you there. Yeah. If that was the case, SLS wouldn't have performed to the 99.7th percentile, dude. By that logic. It's always going to cost... I mean, I agree with you that it's always going to cost the same amount of money no matter what way you do it. Which is why I don't have a problem with one way or the other. You know, there's a lot of SpaceX fanboys out there that are like, oh, SpaceX's way is the best way. Yet SLS has already flown. Funny how that works. Anyway. I mean, I've always said that even with SpaceX's rapid implementation, it's still going to take time. You know why? Because at the end of the day, building super heavy boosters, building stuff that goes beyond low Earth orbit is not twice as difficult as building a rocket that goes to low Earth orbit. It's like 4 or 5 times more difficult. We're talking a 2 to 3 fold increase in difficulty. It's always going to cost more money. I mean, but to say that one way is designed to burn money and the other one isn't is kind of... I don't agree with that. That's not right. Do we have 4K SLS videos yet? We don't, but we have this. Does this help? That's what I'm saying. It's just the same expense, just with a higher risk of wasting money for trade-off or going faster. Oh, okay, yeah. I get what you say. All right, cool. I thought you were trying to tell me that NASA's way was a waste of money. I was about to slap you, dude. I was like, shut up. Thank you for clarifying. I was about to bring the hammer down, man. I was about to bring the hammer down. I'm serious, dude. I know you, dude. I know you wouldn't mean that, but sometimes I'm like, wait, what? Gotta stop doing that. I'm just so used to getting hate for liking SLS. I've been traumatized, man. Both methods have their advantages and disadvantages. Yep. Bad choice of words on my part. I was saying burn money the same way you burn fuel to get somewhere. Yeah, okay, yeah, I got you. Yeah, in that case, yeah, dude, I'm with you. I don't disagree. Either way, it's a zero-sum game, dude. Because it turns out when you build a rocket that goes to the moon, it's expensive because guess what? You can't find a cheaper way to do physics. Funny how that works. No rocket is a waste of money. Well said, Cirrus. Well said, man. Absolutely. I 100% agree. I like all rockets. I don't really care who launches that. Well, there are certain people that launch rockets. China. And the rockets come back down and they hurt people. They got a word for that. It's not rocket, it's missile. I don't like that. You know, especially in a peaceful application, but I digress. But genuinely, I like all rockets, dude. And I try to hold everybody to the same standards, you know? That's part of the reason why I don't cover Chinese launches. Not that they stream it anyway, but... and that's why I'm so critical of their space program, dude, because... safe space flight, there's rules. There's rules for space flight. And part of those rules is making sure debris from space does not come back down on people and hurt people. Because the second anyone does that, it doesn't matter if it's China, it doesn't matter if it's SpaceX, it doesn't matter if it's NASA. I mean, NASA would never do it unless it was unintentional, but NASA ain't in the business of that. You know what I mean? Anyone where debris comes down from space is just going to give people more fodder for being against spaceflight, which is why I'm so critical of, you know, stages that come back down and land in a village and kill people. That's, at some point, someone's going to use that as fodder for a reason to say, oh, spaceflight, you're not helping people down here. Blah, 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 blah. Now, don't get me wrong. I usually don't listen to people that say that stuff because... the truth of the matter is that spaceflight improves quality of life. You know, that whole global positioning satellite thing. Yeah, you need rockets to get those up there. Funny how that works. And if you're building a rocket that can deliver a GPS satellite up there, it's not that much of a stretch to just put people on. I mean, it is actually, but don't tell them that. We need to protest gravity then. Damn thing has gotten off easy. Yeah, let's hold gravity accountable. If my quick Google searches are correct, SLS Block 2 could almost put a shuttle orbiter to TLI. That's too much, Zay. 60 metric tons TLI is way over-engineered for the application. That's like going to the grocery store in a semi-truck. That's too much. You don't need that. 45 metric tons TLI is enough to get down to the surface and back. That's enough to move a vehicle that has the delta V between a lander and a command module to get down to the surface and back. 45 metric tons TLI. That's the key. If SLS can get that number, then we're good. You have a pathway down to the surface. My problem with SLS is that out of the box, it did not come with that. Yeah, that's my big gripe with the SLS program. It should have had the EUS from the start, but somebody thought that engineering two types of upper stages, even though one of them already exists, would be a more cost-effective solution than engineering one. Wait, what? China's space program kills some people? King, some of their launch vehicles launch from inland, like the Jinquan Launch Center. It's out in the Gobi Desert, and it launches east. The Gobi, where the launch site is in northwest China. This would be like NASA launching from Seattle and dropping stages over Montana. Is it going to hit somebody? Montana doesn't have a lot of people in it, but can you see NASA doing something like that? That's a really bad idea. And that's what they do. Stages land in freaking villages out there. And they're using hypergolic propellants because Long March 3 uses unsymmetrical dimethylhydrazine. Even if that stage doesn't land in a village, if the winds are blowing in the direction of a village, everyone in that village is going to get gassed. Like, I don't mean to be like straight to the point with this stuff, but I kind of have a problem with that. Like, I'm just putting it out there. Like, if anybody looks at that and says, yeah, that's fine. Yeah, you might be a piece of trash. Like, whoa. Yeah, that's right, Wiz. Mm-hmm. Yeah, dude. Yeah, no, Forge, we don't need to look at those. Those pictures just piss me off. Yeah, so, yeah, King, I got a little bit of a problem with what they do over there. There's a reason why I won't do it. I won't cover their space program. I just won't. I won't do it. Yeah, Maverick, bingo. Mm-hmm. It was an accident or on purpose? It's not an accident, but I'm sure the Chinese space program doesn't want people to get killed, Razzie, but it's not an accident and it's not on purpose. It's that they don't care. That's my problem. You know, like in the West, you know, there's that whole human life thing that we value. We value individuals. That's kind of important to how, you know, our whole civilization works. We value human life or something. Clearly that's not the case in other places. Yeah, Stim or King, not Stim. That's SITM, not STIM. Yeah, King. That's why I don't really talk about the Chinese space program too much. Now, don't get me wrong. I still read about it, but I don't want to talk about it on here. No way. Talk about NASA because they actually care about human life. Yeah, sorry, I didn't mean to get it going on a dark note there. Yeah. Yeah, see what I'm talking about? King, peep this. Oh boy. Yeah. Yeah, that's probably not good for the people that were living in that house. Yeah, yeah. There's a reason why. But generally speaking, fellas, I like all rockets. Anybody that wants to attempt to try and go and conquer the Black Yonder up there, I will genuinely root for their success. I don't care who it is, except for them. I'm not doing that. Yeah, right. Yeah, Moto, it's messed up, dude. And I don't know why other people don't talk about it. That's kind like seriously. I don't really hear a lot of people say like, yeah, like that should piss people off. But I guess that's controversial nowadays or something. Anyway, getting too real. Don't want to get too real in here. Let's play Kerbal. Yeah. Let's go do stuff in Kerbal. And, maybe we won't kill Val this time.